challenges and its solution regarding the material of NASA spacecraft mission. So I'll be looking at some materials, and particularly one of them is Kapton. So I'll talk about Kapton, that the material that is used by NASA. So basically, this is the Earth's environment. This is sun on the left side, and this is Earth. This is the night side, and this is the day side. So basically, you'll see that the satellites that are in ionosphere or magnetosphere, or this GEO satellites, or the satellites that which go from other for other missions like solar wind to collect solar wind data, or near Jupiter, they go out of this magnetosphere to Jupiter, or near Sun to collect solar wind data. So they get out of the Earth's magnetosphere. So spacecraft, the challenges for a spacecraft is it encounters ultraviolet radiations, high energy electrons, X-rays, Earth's magnetosphere plasma, and solar wind plasma. So this is the general challenges that any spacecraft would face. Even if a spacecraft or a satellite is inside the Earth's magnetosphere, it can still encounter Earth's magnetosphere plasma. So any spacecraft that's out there is encountering plasma. So for any material to be selected by NASA or other space agencies, there are some tests that material have to go through. So the first is test regarding temperature resistance. So for satellites that will be encountering plasma, the temperature will be much greater than 100 degrees Celsius, maybe to near 300 or 400 degrees Celsius. And also the mechanical test. So the material need to be strong, but the mechanical tests, they don't necessarily take the strongest material. The material need to be strong, but it need to be lightweight. The other is the environment and radiation test. So obviously, as I discussed, any spacecraft or satellite will encounter plasma, UV rays, and high energy electrons. So the material need to be tested around these environment, and of course, in the end, chemicals compatibility test. So the material that I've selected, Kapton, which is the most common material used as a blanket on satellite, it has gone through all these tests. And it is used quite extensively from 1962 onwards. So this is basically the simulator in which all of these tests, this is a US Air Force simulator, and this material Kapton is tested from it. So this is the general structure of a Kapton. So you'll see it's a polymer. So in a polymer there are repeated structures. So word polymer is basically a Greek word from polymers. This basically means many parts in Greek. So you'll see that there is a amide group here, this oxygen double bond with carbon here. This is the amine group also, and phenol, and this. So basically there are two parts. There are basically two parts in this Kapton. It's basically a synthesis of this amide group with phenol group. So after this synthesis, we get this material which is called Kapton. Now, in the book that was referred about material science, they have talked about multiple classes of polymers. So this is basically a copolymer because it has these two groups. This structure of polymer, in one structure of polymer, this is one group, which is the phenol group, and this is the other group, which is the anhydride group, because of these hydrides attached to it, or amides. basically it is called polyimide because of this imide root, and it's a copolymer. There is a homopolymer which is a single chain and only have one structure, repeated structure. But here we have two structures that are going to be repeated in a chain. So this is basically called a copolymer. Plus, there is another thing, as we're using this as a blanket around our satellite. So this one need to be elastic and lightweight. So you'll see that in polymers, this double bond, this carbon oxygen double bonds, this reduces the rigidness of the material. In another poly, like in polyethylene, which is in which there are only one double bond, it is much more elastic than this material. So this is also a property of polymers, that in a polymer, when degree of polymerization is higher, the elasticity is less. But when the degree of polymerization is less, like in polyethylene, it is much more elastic and like that. And also the concept of crystal lattice is different in polymers than in metals and other materials. Like in other materials, we take one atom as a one lattice point, but in this material, in Kapton, which is much more complex polymer than any other material, so in here basically we take